YouTube. Okay, so today we're going to talk about scope, but before I do that, I have to correct the record. I taught you something totally wrong, and this is very embarrassing because I used to teach the logic course at the last university that I was at. So whoever pointed this out, I have to thank you. And so when I teach something wrong, I have to teach it right twice. That's sort of the rule for undoing a mistake. So I'm going to be very particular about how I'm going to undo this. So last class, I showed you the following. So I sort of made a claim that and or are associative. That claim is incorrect. Right? What I should have said, what was correct, was and alone is associative. And or alone is associative. But mixed, they're not associative. So I gave you this example, and I bracketed it on either end to show you that no matter how you bracketed, that I got true. Now, that was just pure luck, right, that this ended up happening like this. So let me make a small modification to the question, and it's going to change everything entirely. So instead of, whoops, bear with me, I don't have my pauses. Well, this lets me show you something else. When I'm writing your lecture slides, it looks like this to me. Right? So a tiny mistake here ends up looking like a huge mistake over there. So if you see a mistake and are like, how did he not see that? Well, it's because I'm looking at the markup and not the slides themselves. Hurry up, generate. Did that work? Yes, we're back at the races. Okay. Okay, so to repeat myself, this was pure luck, and what the thing at the bottom was incorrect, so let's make a slight modification. Instead of having greater than or equal to 3, I'm going to put greater than 3. Right? And I'm going to just type this into the Python interpreter to see what it spits out. It spits out true. Okay? What happens if I bracket across the second or the second Boolean? Okay, so 3 is greater than 3, false. Okay, and it doesn't matter, right, because of the short circuit. So that gives you false. And so that's problematic. And if I bracket the other way around, so 3 greater than 3 and 7 greater than 7 is false, but or 1 greater than 0 is true, so that's true. Right, so clearly there is no associative, well, these operations aren't associative. They don't have that property. Right, so let's talk about this more. So more explicitly, consider that we could have a statement like true or false and false. Right? And that's true according to the Python interpreter. But written like that, it's ambiguous. Right? We're technically not even supposed to write ambiguous mathematical statements. Right? So it's ambiguous because depending on how you bracket it, you're going to get different results. Okay, so this means that an order of operations is necessary for resolving ambiguous logical statements. So can we figure out the order of operations from this example? So given that this is true, which one did Python do? This one or this one? It's the second one, right? So this is enough to conclude that Python will evaluate ands before or. It's not a left to right thing. It's truly a and then ors, right? So everything I said last week was true, except when you're choosing what to bracket, always bracket the ands first. Right? So don't make a decision, look for the ands, and that's where you can throw on brackets. So in the case of ambiguity, and is evaluated before or. And the or and operations are individually associative, but not associative when mixed. There's one more unary logical operation, the not, but unary operations always take precedent over the binary operations, right? Negation always takes precedent over anything else. And not, in this case, will take precedent over and or. So I beg your forgiveness. Sorry for teaching you wrong, but at least now we for sure know that it's not associative. Right? So any questions regarding that before I continue? Right? So I wrote this a couple nights ago, back to regular scheduled programming. And then I laughed to myself because we're literally going back to regular scheduled programming. So I thought that was quite funny. Incidentally, my life is very sad. So I gotta win, take my wins when I can get them. Okay, so we're gonna do a little bit of warm up, and then I'm gonna yell at you guys. All right, so prepare yourself for that. Warm up. So today we're going to be discussing variable scope. A little bit more about scope later, but that basically means, so when you create a variable, there's going to be a limited amount of places in your program which can access that variable, and those places are called the scope. But more on that later. So warm up. I define in my interpreter foo, which accepts no arguments and returns 9. What happens when I call foo? It returns 9. Right. So this is in the interpreter. So the three chevrons indicate that we're in. So we can look at it in case there's any confusion. So yesterday I found out that in my other course it was cutting it off. So is everything there visible? Yes. Okay, so what did I say? I said def foo return, was it 9? Okay, so if I type in foo, I get 9, because this is the interpreter. I can assign the answer of foo to A, and then it won't print. Now that I'm in the interpreter, what happens if I type this? Just foo. It actually just returns, so foo itself is a function. So I guess you're right. I begrudgingly acknowledge that you're correct. So foo is a function, right? So when I type foo, that's basically a fancy way of saying, oh, foo is the name of a function which exists at that memory address. That's not really that important, but that's what's contained in that statement. So there's a difference between typing this and typing a function and telling it to evaluate. So let's just pop this over somewhere else. Okay. Bar. I'm going to define a function called bar. It's going to accept x. It's going to set x equal to 8, and then it's going to return x. So what happens when I call bar of 1? What happens when I call bar of 2? All right. You guys feel warmed? Because now you're going to get yelled at. Regarding print statements versus returns, right? Here's a function which returns, or doesn't return, prints, right, the square of a number. Okay. What happens when I do this? It prints 4, right? Because you told it to print 4. Is this true? Is this true? Yes. Okay, so when you don't put a return statement in a function, Python is going to put one there for you anyways. It's just going to assume the very last thing in your function is return none, right? A function is something which is obligated to map an input to an output. So even if you don't want to output anything, you have to return none, right? Because it's going to force you. So do you see a problem here now with returning versus prints, right? If I set a to the square of 2, I expect a to have the value of 4, right? So this is a big problem if it doesn't evaluate to 4. So let me go back into my interpreter here, because I feel like here's the problem, right? So I say def, let's add 2 numbers together, and here I'll say print x plus y, okay? So if I'm working here in the interpreter, this seems to be working perfectly, right? But again, is 5 equal to the addition of 2 and 3? No, it's not. Also notice that 5's still printed, right? Even though it's not something included in the calculation, right? So that's also irritating, right? When other stuff is printing to the console that you don't expect to be there. If I do this instead, right? I can do this, and it will print 5. I can do this, and it will print 10. But now I can say something like this, and it's true, right? Or I can assign the answer to add 2 and 3 to a variable, and then have that variable, right? So printing, like generally speaking, there are no instances unless we explicitly tell you where a print is going to be necessary. You're not developing user interfaces, right? We're developing very basic, simple functions that do one thing. So generally speaking, never use a print, unless you're doing it for yourself, right? Unless you're using it for the debugger, unless you need to prompt the user for some type of input. But there seems to be this understanding, maybe from the high school curriculum, that every function should take input from the user and print something to the screen. That is not the case. When you're given an instruction, follow the instruction very directly, right? Any ambiguity in the instruction. So we had a lot of people saying, oh, should we include test cases? Well, suppose you didn't include test cases, and then I said something like, I'm going to grade you down because you didn't include test cases. You would be totally in your right to say something like, but the assignment never asked us to include test cases. And then I would have to say something like, oh, okay, I guess you're right. Never mind. I'll have to give you your marks back. Right? So don't start attaching other things to the assignment that like we never asked you to do. Right? Because you're going to do something wrong, I guess, or you're going to give us something that we're not expecting. And furthermore, when you go work at a company and they tell you to do something, right? They're not going to be happy if you start attaching extra stuff to your function, right? We give you something. So a print statement is a fairly severe side effect, right? If I wanted to add stuff together 1,000,000 times and you're printing something, I'm not going to be a happy camper that my console is now been taken over by your program, printing out every evaluation of add that happened in my console. Furthermore, print is an expensive function, right? When you print something, Python's saying, okay, we got to wait now for the computer to hand over access to the monitor, right? That takes a long time to run, right? So in my addition statement, by far the most expensive operation in that addition function is the print, right? So you're annoying me by printing stuff to the console that I don't expect to be there, and you're slowing down my computations by including an input-output operation that doesn't need to be there. So I implore you, follow instructions precisely, right? And don't interpret lack of instructions as ambiguity. Right? So if it doesn't say to do something, don't do it. Right? Because this is very important when you start doing your midterms and exams. I can't tell you how many times people have lost 5%, 10%, 20%. Once someone lost the marks for the entire first section, simply for not following instructions. Right? This every year we have to wrestle with the first year students to follow instructions. And for the life of me, I can't understand why. Right? But please follow instructions so I can give you as many marks as I can possibly give you, because I want all of you to be A students and go out to Google and Facebook and make tons of money, right? So, okay. I'm still not finished yelling at you about this print stuff, but that's partially the rant. Okay, so if your function doesn't have a return statement, put one in, even if it's returned nothing, right? So it's explicit to you and the people reading it that it should be returning nothing, right? And stay away from prints. You should really never need them. Right? More warm-up. Foo takes a value x and returns x plus 2 and x plus 3. I say foo of 10. What happens? Why not 12, 13? Yeah, so remember what I said like a few lectures ago. Anything after the first return statement is ignored. Right? Except like syntactical errors, right? Everything that you type into the computer has to be syntactically correct, but some of it may get ignored. What happens when I assign the answer of foo10 to answer? Well, answer will get the value 12, but nothing will print in the console because it's an assignment. To get the value of answer, I can say answer and hit enter, and then it will say 12. Right? So everything after the first return statement is ignored, right? And some nuances about the console, right? So this is also sort of weird, right? Because if you open a Python console like this, like an interactive shell, then functions are going to print out their returns. If you do it in a file and call Python, or maybe in one of the IDEs, it doesn't necessarily return the function call. So you can always put prints, but know that there's this weird nuance between the interactive shell and calling it. Here's another function foo, which prints x plus 2 and then prints x plus 3. What happens when I call 10? Foo of 10. 12, 13. What happens if I assign what foo's returning to answer? It still prints 12, 13, even though I don't want it to. And furthermore, answer is what? None. Right? So okay, good. So now do you now sort of get the feeling why prints and returns are like very different, right? And print is just not the. Someone told me that his high school teacher told him that returns were too complicated, so they're only going to use prints, which baffles me because they've been doing math for like 15 years, right? Anyone who knows how to evaluate f of x equals x squared can understand what a return statement does, but who am I to criticize? I'm a professor of computer science. That's who I am to criticize. I have a PhD in this discipline. Okay, so specifically more about scope. So imagine I create a program and I write some type of variable and I give it a value. Where is that name available to us, right? Because if you want to make like multiple functions, f, g, h, and they all want to take a value like x, right? F of x, g of x, h of x. We want those x's to be different, right? We want the x of the f to belong to f, and the x of g to belong to g, right? We don't want any cross-pollination of these names, right? So the scope of a variable is the collection of places, like functions, procedures, control structures, that can access its value. Okay, so I'm going to show you bad code today, right? In order to try and trick you, right? But generally speaking, so I'm going to define two terms soon, global and local. And generally speaking, when you want to use something as a global variable, you should specify that. Because if you don't, the Python interpreter is just going to make assumptions. So I'm going to show you what assumptions the interpreter is going to make, but with the caveat that this code is poorly written, right? Because you shouldn't have to really think about what the interpreter is going to do. It should just be clear from what you have written. So x equals 2. Y equals 3. Foo is a function which takes nothing and returns x. And bar is a function which takes nothing and returns what foo returns times y. So let's do it step by step. What happens when I call foo? Returns 2. What happens when I call bar? Returns 6. Okay, so when I call foo, it steps to here. It goes return x, and it says, oh, okay, yeah, I actually do have available x up here. So it says 2. When I walk into here, I call foo. It's going to return x, which is 2, and then I'm going to multiply by 3, which gets you 6. Right? So in this instance, x and y are set to have the global scope. Right? The values of x and y are available to every function that comes after. Right? If I put this x and y after foo here, then this would have thrown an error, right? Because x is not yet defined. So a global variable, or simply global, is one that can be accessed by all functions in your program. Anything declared outside a function will act globally by default. Right? A function declared globally, that shouldn't be function. A variable declared globally is said to have the global scope. I don't think you can have global functions, but that may be wrong. Okay, so generally speaking, you want to avoid using global variables, right? That somehow when you use globals, that has the tendency of creating really weird effects in your program because some function may accidentally modify the global variable and screw things up everywhere. But there are certainly instances where a global variable would be appropriate. Constants are a good example of this, right? The value of pi should be the same everywhere. So there's a PEP convention regarding declaring constants. So declare constants in caps. But note, nothing's preventing you from changing the value of a constant. Right? So just because it's in caps doesn't mean you can't. Okay, I'll make it very explicit now. What is going on? My computer is exploding. Yep. Okay, so I can say pi is equal to 3.14. I can sort of like manipulate pi. Pi plus 2. I can have a function which returns x times pi, right? And that works. But no, I can actually change the value of pi. Pi is exactly 3. No one watches Futurama. Okay.
Okay, so some packages have done before, you actually have to declare a variable or constant. It has to be either a variable or constant.
There is no constant declaration in Python,
Okay.
right? So it's like, so whenever you add these things, so Python's a very highly interpreted language, right? So that means that you're going to get a lot of allowances to screw up. Like when we're talking about functions like languages like Fortran and C, You get a lot more of these like detailed things, but it's a lot more error prone when you're working in C. So it is correct, right? For those of you who know how to program in C, there is a constant variable definition which prevents you from writing to that variable, but that is not the case in Python, and that's all that matters, right, for this course. X equals 2. Right? Now I declare a function foo, which sets x equal to 7, and then I return. So I call foo, and what's the value of x?
2.
Who says 2? Who says 7? Who's abstaining? It's 2. Why is it 2? Well, despite having the same name, right, the assumption when you create a variable in a function by Python is not that that variable should be global, right? It's going to make the lazier assumption that, oh, okay, you want a new variable, you got it, x, right? So foo has access to a variable called x, which is equal to 7. But that x belongs to foo, right? Which is different than that x. So this is why scope is confusing, right? Because we have things that are exactly the same name, but their scope is contextual, right? So it's less the name that matters and more where the name was defined, right? So since this name was defined in the console outside of a function, it will be globally accessible if you choose to access it. But as soon as you declare something in a function like this, it's going to make it local. Yes?
When, for example, you do an increment, is it the same like variable that the number is going up, or is it a new variable in another place in memory?
So you're talking about when you're like counting through a loop or something like that?
Yeah.
So like x equals x plus 1?
Yeah.
That's the same name, right? That gets utilized. And I do have some type of example like that, which I'll walk through. Okay. This is the appropriate way to use a global variable, right? So again, I'm writing terrible code for the rest of this class for the purposes of demonstration. But when you want to use a global, you just put global x as your first line, right? So you're telling the function foo, look, when I tell you to use x, you are not to use a local version of that. You are to use the global version of x, right? You don't have to declare local variables. There's another difference between C and Python, right? It's very forgiving. So here, if I call foo, what's going to happen? If I now ask for the value of x? 7, right? So there's a big difference between specifying global variables and not specifying them, right? So again, back in this case, right? I don't want to see questions on Piazza. Why isn't this returning 7? Right? Because again, it's cast as a local, and if you want to use global variables, always use the global key name. Did we do this one already? Okay, so define foo, x equals 2, return x. That should be easy. So what's foo? 2. I think this is why I asked this question. What's the value of x here? So what's the scope of x? To what? To foo. And this x is outside of that procedure or function. So I would expect the compiler to complain, because at this point, there is no global x. And so it's going to say, what are you talking about? There's no x here. There's an x in foo, but when I'm typing outside of foo in the console, I'm not in the scope of that variable. Right? So this is confusing. You have to go do your lab. I'd really recommend going and doing the labs this week. This is something really which requires you playing around with the console and changing things around. But you'll get a feel for it. The reason that it's confusing is because the same name can have different values depending on context. So you're going to have to learn to appreciate context. So again, outside of foo, the variable x does not exist. X is a local variable. Okay. X is 2. I define foo. I say x is equal to x plus 2, and I return nothing. I call foo, what happens? This is a tough one. Okay, so let's step through it. Right, so I declare a value called x and set it to 2, and it has the global scope. Okay, I define a function foo. and it's going to go in. I didn't declare anything global. It's going to create x, so still technically it could be global, but here we're, sorry, this x could technically be global, but this x as it's being defined in foo is going to be assumed local, right? Because I made no global declaration. So if this is local declared to foo, then this has no value at the time that x is launched or x is created, right? So this is going to say make a new variable called x and make that new variable equal to the new variable plus 2. Well, I can't say that, right? X has no value here yet, right? Despite x having a value up there, right? So again, as soon as you say this, x equal, you're done. Unless x is declared globally, x equals indicates to the compiler or Python, this is now to be locally cast. So by the time it gets to here, it's treating x as local, and it has no value. So when foo creates x, it becomes local and thereby has no value at the time of assignment. More. X equals 2. I define a function foo, and now I declare x to be global, and I return nothing. So I call foo, it returns nothing. I ask for the value of x, and I find that the value of x is 4. I call foo again, and I find that the value of x is 6. Okay? So x is declared once, and it's not like it keeps getting declared over and over again, right? So I can define a function which somehow is incrementing a global variable. But again, it's because I use this global keyword. X equals 5. I define a function called foo which accepts x and returns x. What is foo of 7? Right? So this is another way to declare a local variable. It's just happening sort of in the function header. Right? So by this point, Python is interpreting x as local. Right? So it's not going to see it as 5. So when I pass 7 to foo, this gets set to 7 and it returns 7. What is the value of x here in the interpreter outside of foo? 5. Perfect. So despite having the same name, there are two x's in this instance. The local x of foo and the global x of Python. X equals to 5. Foo is a function which takes y and returns x times 5. What is the value of foo of 7? 35. Why would you say error? Right? Foo takes y, so it's cast y as a local. So this is going to be 5. I didn't say anything about x, so the assumption by the compiler is that this will be global if it's available. Right? So this is 5. Right? Trickier one. What is foo of x? Huh? 25. Why? So foo takes the value of x, which is 5, passes it to foo, which sets y to 5, and then it returns x times y, and x has a value 5, and y has a value 5, so it returns 25. So locals and globals can be mixed in computation. Again, I should have written global x here, right? I'm just sort of showing you that in case you find some weird behavior of your function, this may be happening, right? Absent of a global declaration, Python is going to look for globals, and if it's there, it's going to use it, right? But please write in globals. Right? X is 5. I define, oh, what's happening here? Okay, well, I guess I spoiled the surprise. So I'm trying to mix a bunch of stuff here, right? I'm making a global declaration of x, setting it to 5. I'm making a definition of foo, and I'm taking in a value called x, and then I'm trying to say global x. Well, what have I done here? I've said, well, create a local version of x and use a global version of x in this namespace. And Python's going to say, no, you can't have two things named the same in the same namespace, right? Before, we had an x in the global namespace and an x in the local namespace. Here, I'm trying to make two x's in the same place. So it's going to complain. You can't have a local and global copy of x at the same time. Okay, so for the final part of today, the lab this week makes reference to something called the design recipe. And although I'm not a big fan of recipes, because it gives the impression that there are steps that you can follow to solve any question, which is false, this is actually not a bad recipe for designing new functions. So I'm going to post this to my section of the course webpage. It was written by a different professor maybe a few years ago, and it's not bad. I've sort of rewrote it in my own words. His is a little bit longer, but this is the gist of it, right? So suppose that you're just sitting down at your computer to write a program, right? And this isn't an assignment, right? So when we give you an assignment, we're usually saying, write a function with this name that takes these inputs that returns this, right? When you're writing for yourself, those 3 steps have to be done by you, right? So the first thing that you should do in writing a function is to ask yourself, what is my function doing? And then to try to give a name so that anyone who invokes your function will also know what it's doing. So we've seen some good examples of definition names this class. So add is an example of a good variable name. Foo is an example of a terrible variable name because it says nothing about what it does. This underscore function underscore adds underscore to underscore variables is a bad function name, right? So you have to sort of strike a balance between being descriptive and being very long-winded, right? So, and I have no prescription for this. You just sort of have to develop a feel. Although it is useful if you have an IDE which allows you to auto-complete long variable names. So in my VS Code, I don't mind using very long variable names because I can hit escape and it will fill it in for me. So you should try and find this functionality. Also, when you're working in the terminal here, so that's all of the folders in this current directory. I can hit D, and then I'm just hitting tab on my keyboard, and it's showing me everything that's with D. If I get enough of it, I hit tab and it will complete it for me. So you should try and use this tab completion or escape completion. It will make things a lot easier, right, to let the computer complete these things for you. Okay, so step 1, choose a name. Step 2, write a function header and its doc string. Assume your function is working as you would like it to work, and throw in a couple examples. Right? So this is weird, but this is very effective. Like when you're trying to design a library, you basically want to ask yourself, well, if this library was already working the way that I wanted it to work, how would I be calling it? How would I be using it? Right? And then write all the names of the things in your function, and then specify what they should be taking in and returning, right? So I can very easily read through this. Oh, this is a function. It's probably testing if something's a prime. Oh, it's testing if an integer is a prime, and it's going to return a true-false value. Going into my doc string here, I say, oh, okay, so some usage. You call isPrime7, it should return true. I call isPrime8, it should return false. Okay, so step 1 and 2 is basically write a function, header, and a doc string. Add to your doc string a short and concise description of what your function does, right? And there's a tendency among new programming students to make these descriptions ridiculously long, right? For sure, your description shouldn't be longer than the code that implements it, right? You should be able to give a very short description of what your function does. Otherwise, the function that you're implementing is doing too much. It needs to be broken into smaller pieces. So this is called abstraction. We'll talk about this. So write a short and concise description of your function. So in this case, this is a function called isPrime, which returns true only when x is a prime. Right? So I can summarize steps 1 through 3 as write a header and doc string. Right? Step 4, write your function. I'm not going to do it because this one's super hard. And make sure to return your answer. Should we print our answer? No. Should we return the answer? Yes. So I repeated this like 10 times for the last class. I'm going to repeat it once more for you. Print is bad. Return is good. Return. Don't print. Right? Remove print from your functions before you submit anything. Okay, here's the other thing. So how much time do I got? 10 minutes maybe? 12 minutes? Okay. So I'm just going to show you how we test your code. Right? I don't want to be in that one. I want to be in this one. So suppose we ask you to write a function, what was called volume, something like this. And you take an x, y, and z. And what were you returning? Here's the answer. Spoiler alert, it's the product of everything. Okay. Now, I think most of you are imagining that I'm going to look at your submission, load it into my Python interpreter, and do something like this. Okay, Billy submitted this. I'm going to type in 1, 2, and 3. That's 6. Great. I'm going to do 2, 4, and 6. 48. Perfect. Now I'm just going to go and do it for the remaining 1,000 of you. Right? That is not how we do it. We're going to use the power of computer science to automate this. Right? So I'm going to do something like answers. And I'm just going to check. I'm going to put an input here, like 1, 2, 3. And I'm going to pair it with the answer. Right? And maybe I'm getting really ahead of ourselves, right? So I'm showing you a lot of syntax that we're not currently that we don't currently have. So don't freak out too much, right? So 2, 4, 6, or 2, 4, 6, and the answer should be 48, right? So we've defined some type of list which contains inputs and outputs, and then we're going to do something like define test student, right? Which will take your volume function, right? So I'm just going to call it f. Arbitrary function, and we'll take our answers, and we'll do something like this. And I'm going to use a print just for demonstration purposes. Right? So we haven't done, so I'm showing you a lot of stuff that we haven't done. But I can basically say for x, y, z, answer, right? In our answers, I'm going to print the f at x, y, z equal to answer. Right? So I'm going to do something like test student. I'm going to give it your code. What's up? Did I do something wrong? I misspelled. Oh, student. It's like a smaller student. Right. I pray that this works. No! Oh, sorry. Right? So what's happened? It's like step through these like input-output pairings, and like we're gonna do maybe like 100 of these pairings, right? So your code is never reviewed by a human unless you did something like break our server, right? Which I wouldn't recommend you do, but was super fun when I did it when I was in university, right? Okay, so just keep that in mind. Like the computers that we're testing your functions on aren't even connected to monitors. Right, so your prints are just being printed to the void, right? So no prints. Next week we're going to be talking about. So next class, I'm going to basically design a dozen functions with you guys. It's hard for me to do this because we still don't have things like for or ifs, but I'm going to do my best to come up with interesting stuff. You guys have a nice day.